Good morning. This lesson is from our Trig-Precalc class, but before I get started, I want to say I hope that everyone is doing all right out there. I think this is chapter 6, lesson 4. I don't know. I'll title it correctly in the title. But what I do know are our 3 goals for the day. Our first goal is going to be an explanation why the angle side-side pattern does not ensure triangles are congruent. Our second goal is going to be an explanation of why a triangle with an angle side-side pattern and the 2 triangle case makes 2 triangles to solve, or this condition which makes 2 triangles to solve. And our third goal is going to be solving both triangles when we have the 2 triangle case. Alright, so let's go ahead and jump into our first goal. I'd like to do a little bit of a review here. So congruent triangles are triangles that are the same size and shape. Methods that guarantee triangles are congruent are side, 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 angle, side, angle, angle, side, and hypotenuse leg for right triangles. Here's the argument why angle, side doesn't guarantee congruent triangles. So I'm going to show you over here why it doesn't guarantee it, but let's just do a little bit of reviewing here. I need to talk about circles. So a circle is a set of points on a plane that is equidistant to a point, the center point. So what I said here mathematically, translated very simply, is a circle is a flat object, that's what it means to be a plane, and you have points, a set of points that are all the same distance from one point, which is the center point, right? Any segment that connects the center point to a point on the circle, to a point on the circle, will be equal in length. These are the radii or radius of the circle. So if you take a segment from the center to a point on the circle and another segment from that center to another point, those segments must be equal because by definition it's a set of points that are equal distance to one point, right? So the key idea about this argument that doesn't guarantee that the angle side can create congruent triangles, the key idea is that we can make 2 different sized and shaped triangles using the angle side pattern. So, first of all, the circles are the same size. Okay, I drew them so that they're the same size. Secondly, angle A is the same as angle D. These 2 angles are the same. That's the angle part of the angle side. Side AB is the same as side DE. That's the first side and angle side. And again, since I have a center point on a circle and I connect that to a point on the circle, that guarantees that these 2 segments must be the same. I'm totally blocking it, I bet. And that means that segment BC must be congruent to segment EF, and that's the second side and angle side. So I hope that you can recognize that these are 2 clearly different triangles, right? The first triangle is a much larger triangle where the obtuse angle is an angle B, and the second triangle is a much smaller triangle where the obtuse angle would not be that location at the center of the circle. Now, this triangle right here, you could actually draw it in here, and I'll show you how it's drawn, right? So I would literally just connect the center point to this point, and now I've got my little triangle that I have right here. So again, this pattern of having a congruent angle and then 2 congruent sides in a row in this what would you call it, consecutive manner, this guarantees, or not guarantees, but this creates a situation where I could have 2 different triangles. So we can never assume 2 triangles are congruent because of angle side. But again, this segment that's created here, this is really going to be the key to understanding the second goal as to why a triangle with this pattern makes 2 triangles to solve. So I'll go over that a little bit more here in detail for the second goal. So hopefully I've convinced you that we don't have congruent triangles in this pattern. Let me erase everything and set up the second goal, and I'll be back. I'm back. So let's go ahead and jump into our second goal. But before I get started with the second goal, I want to share with you some thoughts I had about how I'm going to present this. I was a little worried that I was going to make this too complicated. But in walking through what I'm going to show you guys, there's actually a really important result. So I'm happy that we're going through this because we're going to be able to use the result that we get to help us with our third goal, and it'll explain where one of the measurements come from. So let's go ahead and just jump right into our second goal now. Remember, all the radii of a circle are equal. If a segment from the center doesn't reach the circle, it is shorter than the radii. And if a segment extends past the circle, it is longer than the radii. So if we start with our triangle, where we know the measure of angle A and the lengths of C and A, we have the angle side-side pattern. Now, if we create a circle centered at angle B with radius length A, and we draw a circle, which I'll do up here, and I didn't hide it from myself very well this time, but I'll draw a circle here. And remember, my radius is A, and this is the important part, and this is why I'm actually glad that I'm going through this with you guys. So if I draw a radius of length A, and I come like this, this shows that the height of the triangle is less than the length of A, and it's less than the length of A because B was the center, and this segment doesn't reach the circle, so it's shorter than the radii, which was length A. And I should have made that longer so I can articulate my second point. Let's try this again. And length C is greater than length A because it extends past the circle. Or I can say that the height is shorter than the length of side A, and that's shorter than the length of side C. All right, and so I want to explain to you why this again is a two-triangle pattern, and there's a couple other important things as well. So where the circles intersected side AC, we're going to call that point D. Okay, and our two new triangles are triangle ABD. Right? If I connect that, it's ABD, and I know that this length right here has to be A. And I know that this length has to be A because A is the length of the radius. This is a very important thing to understand. This is because it's the radius length. And this is going to help us with our last goal, and hopefully I'm on the screen here. I better check because I'm getting so tired of having to restart and redo all these. And I'm off. Oh, but you know what? I'll cheat. There we go. Now I'm on. So this is the radius length. So I know that that length is A. There's my triangle ABD, which I drew down here. And then here is my original triangle ABC, which is our second triangle. So the last goal, what I'm going to do is I'm going to come back and we're going to actually work through a problem here when we solve both triangles using the law of sines. And so hopefully I can articulate the way to work through this and make this simple. So let me go ahead and clean everything up. And again, let me really stress that this length on our second triangle has to be A because it was created by the radius. All right. So that's actually a really good thing about this part of the lesson. So let me clean this up and I'll be back. I'm back for the last time, I promise. So let's go ahead and jump into our third goal, solving both triangles when we have a height shorter than the length opposite the angle we know, shorter than the adjacent length of the angle we have. Let me give a disclaimer. You guys are probably going to struggle with this. And I think that if you work out the problem as you watch me work out a problem, I think you'll be okay. But try your best to follow along and try your best to have this video be your guide as you're working out the problems. All right, so you're not going to quite know when you have the two triangle situation, so let's go through through setting it up. So setting up the triangle for the angle side-side pattern. First, rename the triangle. The known angle is angle A. Angle between the known lengths is angle B. The remaining angle is angle C. Rename the side lengths too with lowercase letters A, B, and C opposite their angles. So I'm going to do that to this one. The known angle is angle A. the angle between the known side lengths is angle B, and the remaining angle is angle C. The opposite lengths to the angle are the lowercase letters, so this would be length C, this would be length A, and this would be length B. Okay? And we need to do that because our second part of setting it up is we have to use this formula, and if we do not rename it, our formula is not going to be any good. So our formula is based on a renaming of the triangle. All right, so let's calculate the height here, just so we can verify that we're going to have the situation where we have a height that's shorter than the length A, and that's shorter than the length C. So where did I hide my calculator machine from me? I hid it all the way in the back. Back. Boy, what do I hit it up front? There it is. I hid it behind some books. There you are, calculator machine. So the height of this triangle is going to be the length C, which is 23, times my sine of angle A, which is 38 degrees. And the height of this guy, let's see, 23 times sine of 38 is equal to 14.16, so that's roughly equal to 14.2. So the height is in fact shorter than the side length A, and side length A is in fact shorter than side length C. So that means that we have the two triangle case. Now, I'm going to add to this triangle here. This is going to be kind of hard to follow along, okay? So let's just try our best to follow along here. So remember, this is what the two triangle case looks like. This is also 17. All right, so our one triangle now becomes these two triangles. I have, oh, that's okay. So I have a 23, I have a 17, and I have a 38 degrees. And then my other triangle is the original triangle. Where I have my 23, my 17, and my 38. Okay, so let me just kind of clarify a couple things that are going on here real quick. First of all, I have a little triangle right here that's doing this. So when I have a triangle that has two lengths that are the same, I have two angles that are the same. Okay, so I know that this angle is going to be the same as that angle. I know that fact. All right, now remember the height is shorter and the height is measured at a right angle. This angle and this angle must be acute. Okay, so angle C must be acute. And I'm mentioning that because when we start to use the law of sines here, we're going to get a result. Okay, if this angle is acute, which means it's between 0 and 90, and I'm going to add up to 80 using this idea. If this is between 0 and 90, that means that this has to be more than 90 to get to 180 degrees. So this angle right here, this angle, and I'm going to start to draw in, it's going to get crowded. This angle has to be obtuse. All right, so now that we have this, let's write our law of sines and see what happens. Okay, so the law of sines is going to be sine of angle A. All right, so this is A, we'll call this B. This is C, we'll call C prime C. B, we'll call that B prime because it got cut up. There's A, there's B. We'll call that B prime because it got cut up. But sine of A divided by the length of A, which is 17, sine of 38, sorry. Sine of 38 divided by 17 is equal to the sine of B, divided by the length of B, and that's equal to the sine of C divided by the length of C, which is 23. We do have an equation that we can solve. If we ignore this, we can solve for the measure of angle C. All right, so let's bring this up. Like I said, it's going to get crowded and kind of hard to follow along, but try and do your problems on your own like I'm doing this. Sine of 38 divided by 17 equals the sine of C divided by 23. All right, if we divide away the 23, or we multiply away the 23, everybody, we get that the sine of C is equal to 23 times the sine of 38, and this whole thing is divided by 17. So I can actually now calculate the measure of angle C. Remember, angle C is either acute or obtuse. So when we plug it in, we're going to get a certain value. So second sine of 23 times sine of 38. Close that parentheses and divide everybody by 17 and close all the parentheses. And I get that the measure of angle C is 56.4 degrees. Which means this is 56.4 degrees. And so now we have some information here. So this is 56.4, which means I can find the original angle B. So the original angle B, let's see here, 38 plus 56.4, and then we're going to take that away from 180. So that means that the original measure of angle B was 85.6. Okay, now if I plug that into here, I can find my measure of length B. So let's do that. Let's find that. So I have sine of 38 divided by 17 equals sine of 85.6, and we'll divide that by B. Okay, so let's multiply everybody by B, right? So year times B and year times B, and then we'll multiply everyone times 17. We'll just get rid of all the fractions at once. So the 17s cancel, the B's cancel, and I get B equals, or B times sine of 38 equals sine of 85.6 times 17. Divide that by nobody yet, because I haven't divided away the sine of 38. Let's get B by itself by just dividing away the sine of 38. Like I said, this is going to get just really messy, but we're going where the problem takes us. That's what I hope that you're realizing here. Sine of 38 cancels. The length of B is now going to be equal to the sine of 85.6 times 17 divided by sine of 38. I really hope that I hit record on this. Oh, you're recording. Oh, wonderful. Okay. So let's see here. So now I can find the length of B. So it's sine of 85.6, and we're going to multiply that by 17, and then we're going to divide the whole thing by sine of 38. And that means that B is 27.53 or 27.5. So B is 27.5. All right. Hey, I saw the one in the triangles. Now, we're getting closer to the end. We don't have much more to go, because we know everybody in here if I know that this angle is 56.4, because remember these are the same, so you're 56.4. 56.4 take away 180. Using this idea, that means that this little angle right here is 123.6. And if I know two angles, I can find the third angle. So minus 123.6 means that my remaining angle, the smaller b angle, is 18.4. This guy is 18.4. So that's a terrible 4. It looks like a W, 18.4. We're almost there. We just got to find this guy, and we've solved both triangles. Right? So instead of having sine of b be 85.6, we're going to have sine of b being 18.4. And you know what? Since we did all the work, we can use this result. So we know that the length of b is going to be equal to the sine of, because we're just replacing this number with 18.4, so let's replace it when we're done all the solving. So sine of 18.4 times still 17, right? And that's divided by, what is it? Sine of 38. I'm looking all over the place. This is super crowded. All right. Ooh, let's see what we get here. It better be shorter than 27.5 or we're in trouble. All right. Sine of 18.4. Close up parentheses. Times 17. And we're going to divide the whole thing by sine of 38. And we get 8.71, which is 8.7. And it is smaller. Oh my gosh. So again, like I said, this is going to be complicated. I hope that you can follow along and just do each problem or each part as I'm doing it. And remember, I mean, I do expect you guys to struggle with this. Okay, you're not going to have very many questions on this homework, but I want you to try your best at it and just try to make your problem do what my problem did, and you should be in a good spot. All right. So I'm going to go ahead and end this here. Just give it the old college try, right? I'm going to go ahead and end this here. Again, I hope everybody is doing all right out there. Have a good day, everybody. Bye-bye.